Hello everyone, my name is Yiheng Yuan and my partner's name is Yunpeng Zhao. Today we want to propose our final project about two-finger robotic arm. So this idea is come from one of the character from Spider-Man whose name is called Dr. Octopus. He is originally a scientist who created those four robotic arm to help him building some scientific uh, project, which can never be achieved by the human arm alone. So the robotic arm play a huge role in this project and it's very helpful. So this idea is not just a fantasy comic idea, it's actually in our real life today. So many of the industry already apply the robotic arm to help human produce stuff that can be never done before with our human arms. There are two important rules that the robotic arm is better than the human arm. The number one is the robotic arm will never get tired. As human, when we reduce the certain movements, we'll get tired and lose our accuracy and eventually stop doing the movements. But the robotic arm, on the other hand, will never be tired and will remain the high accuracy, reproduce the same movements over and over again. Another function is that the robotic arm can operate under the certain condition where it's endangered to our humans. For example, the high temperature environment where the human cannot stand, but the robotic arm will still functionable under certain condition, which is very helpful for achieve the certain goal that a human can never achieve before. So that's why we want to recreate this fundamental robotic arm and to explore the potential add-on we can use for this robotic arm.
Hi, next I will talk about our goal in the project and some technical details we aim to achieve finally. For our goal, due to our passion for robotic arms, we want to build a simple robotic hand to explore this field. In this project, we aim to construct a two-finger robotic hand that can move around and grab small objects. Additionally, we plan to implement a replication function for this arm. This feature is widely used today. For instance, if a photographer wants to capture a video with intricate camera movements, they could mount the camera on the robotic arm and manually guide it to record a series of movements. The robotic arm can then accurately and smoothly reproduce the camera movements for them. This is a very cool function, and ultimately we want to include a button to record and redo the movement for the replication function. Regarding technical details, here's the diagram I've drawn to illustrate our initial concept for building the robotic arm. We plan to use three servo motors to control movement horizontally, vertically, and for gripping actions. The arm structure will be made from popsicle sticks for their lightweight and relative strength. For control mechanism, besides the replication button, we intend to use a joystick for arm movement function and either a button or a potentiometer for controlling the grip function. A significant challenge we foresee right now is figuring out how to control two servo motors with one joystick. And additionally, we are still refining the details of the replication function. And next, this is just a simple list of all the material we might need. As I said above, we mainly use servo motors to move the arm, and we also use a few gears like joystick and the button to control the arm.
So besides the fundamental robotic arm, when we have time, we want to try out some potential add-ons. So we select five sensors that will be very helpful on applying to the robotic arm. And then, so this is something we want to try out when we have time in the future, and then to see which can performs better when create our robotic arm.
And the next, we have a rough timeline to make sure we can finish this project on time. So we will try our best to make our design mature this to finish our design this week and begin to collect all the materials next week. Then we can check our design based on the material we have at that time to make sure the design works. Buying material takes time, so we have 1 week. We allocate 1 week for it. Then is assembling. We will assemble all the materials we have and finish all the coding part this week. We may not be able to do that, but we will still try our best. So we plan to use week 9 for final test right now, but we may also use that to finish our ARM project. So that's all for now. Thank you for watching and have a good day.